Okay, a very warm welcome everyone, and I'm delighted to introduce tonight's speaker, Andrew Garrad, who is beginning his term for 3 years as a Royal Academy visiting professor in renewable energy with us, and we're delighted to have him with us. I'm sure you're aware of Andrew's many accolades within the wind energy industry. He really has been a leader in the sector for 30 years plus now, I guess. And of course, his greatest achievement of all is becoming a member of staff here at Bristol University. So I guess it's really important to say that Andrew has already been supporting the university very strongly for the last 10 years, and slightly more than that. He's been delivering guest lectures, he's helped us launch a course in wind and marine energy, and he also sits on the external advisory board of the university's Cabot Institute. So his commitment to the cause has actually been so great that he actually gave himself a heart attack coming to give a very similar lecture to this a few years ago. And yeah, well, please don't do that tonight, Andrew. That's the only request, okay? And he'll be continuing those activities over the next 3 years in terms of lectures and carrying on his involvement with the Cabot Institute. But he'll also now be able to give much more support to undergraduate projects. And one of the exciting areas that he will be involved with within the coming years is both the setup and delivery of a new engineering management MSc, which will have a pathway in sustainable energy. So there are some really exciting developments within the university around the area of sustainability. Andrew has certainly been a huge inspiration to me within my own career, and I'm completely certain that over the next 3 years, he's going to do the same for many, many students here at the university. So a very warm welcome, Andrew. It's a privilege to have you joining us, and I'll hand over to you for tonight's lecture.
Thanks very much. Actually, I have had a job here before. I was an honorary visiting research fellow in 1990, I think. Who remembers Martin Lowson? Yes, well, so Martin sacked me in a very actually uncharacteristically diplomatic way, I would say. But yes, so anyway, I'm back again now. Actually, something else that Martin did, just when Alan Chambliss arrived, and Martin was telling me that Alan was here, and Martin said to me, oh yes, we've got this new chap, Chambliss, but you won't have anything difficult enough for him. And I said, I'm not sure, Martin, was that meant to be a compliment to Alan or an insult to me? But if you know him, you'll know it was neither, probably. Anyway, so I am a very long title there, and I tried to be the visiting professor in wind energy, but I wasn't allowed to be. But you're going to see that actually I'm going to talk about wind energy with just a glance at the others. So I apologise there if anybody's come to hear about PV or others that you're not going to. So I've allowed it also to be a little bit personal, since it's meant to be my inaugural lecture. But the main focus of this lecture, or the main audience for me, is the younger rather than the older members of the audience. And I think it's pretty clear probably right now that energy and climate, but energy specifically in my case, is political. And up to you, as people starting your careers, to play your part in the political changes that are necessary. What I'm going to endeavour to show during this evening is that engineers will probably almost always rise to the challenge that's given to them, but we're probably not particularly good at forming those challenges or articulating those challenges. And I think the key thing we really need is to get the right policy framework within which to work. So the talk was called Technology and Politics, and I guess that's what I've also been doing for a long time. And it's political everywhere. So here's a picture in Beijing, and the reason why last year China installed more wind energy than the whole of the rest of the world put together is really, I think, because of the air quality in Beijing a few years ago. So in a central control economy, you can make a decision that fast, which is, right, we better clean this up, we better do something about it, and they have. But this is a sort of sign of democracy, which of course is a little bit of a poignant statement right now with what's going on in China. But I think there was a public rebellion about air quality, about environment in Beijing, which resulted, at least in part, with a huge amount of activity that they've got in wind, which we as a company were very much involved. And of course, this is very current news, so what happened last week in Saudi Arabia, and what might have happened. So there was a suggestion that oil price might have gone up to $300, which of course some people might say was a good thing. That's a matter of debate which we could talk about later on. But the political nature of energy is, I think, very clear. So why are we interested in renewables? What are we trying to do? So the two previous slides about oil clearly give us a worry about security of supply. Where will we get our energy from? And also, how much will it cost? So how sure can we be of the cost of energy in the future? And in maybe rather a parochial way, politically, the creation of jobs in a new industry are very important. Now, I put those 3 points there before even mentioning climate change. And the reason for that is that this is essentially a political slide. And if you're talking to politicians, those 3 things are probably much more important, although they shouldn't be, are much more important than the bottom item, which is dealing with global warming and climate change. So the reason for that, and perhaps this will change, and I do believe we are at a very important stage of development of this whole argument right now. The reason for that is that, traditionally at least, party political time horizons are 3 or 4 years, whereas energy planning is 30 or 40 years. And those 2 time horizons are completely incompatible. And so getting any government to actually plan something which deals with climate change or deals with clean energy. When I started in wind, we hadn't heard of climate change. We just talked about slag and ash and clean energy. So these 2 timescales are different by an order of magnitude, and that gives a major difficulty in getting things done. Perhaps we are at an important change point now. I think perhaps we are. Again, perhaps we can discuss that later on. So what are we dealing with? The climate change, this is a very powerful photo, which I'm sure many of you have seen before, and then security of supply. So these 2 images, I think, go quite well together and summarize the problems which we're dealing with. Now, a lot was made about the Paris COP, much less about the Katowice or the Marrakesh or the Bonn and the upcoming Chile COP. So this was a big deal. And I think it was an important point, but of course we do have to wonder what has happened since. So these people here are making a very clear gesture of victory, but we have another guy who came on the scene shortly after that with a similar but opposite gesture. And I'm sure you're all aware that he is not our friend, although in a sense this doesn't matter as much as you might think, because lots of American states, American cities have got on with their own policies, notwithstanding the federal policy which is decided by Trump. So this, you can see, is the political background. Now, I think with age, I've become, although I know inclusion and democracy and all those things are terribly important, I think I've become more and more dictatorial, at least in my inclination. And I thought I'd just show you a couple of things, actually, apart from the fact that it's got a rather nice rolling up of these vortices, which is a different part of the conversation. So really, pretty much overnight, we managed in Europe, but in Britain in particular perhaps, to stop smoking in public places just by saying, don't do it, stop. And it wasn't all that traumatic, and it really worked. And so making a strong decision about something can be important. I had an interesting encounter with a plastic bag over the summer. I was fishing for mackerel. And I got a lot of mackerel, and I took them back and I gutted them, and I put all the guts in the plastic bag. And I was just about to throw the plastic bag away. And then I thought, actually, I had to try quite hard to find this plastic bag to take with me on the fishing trip. And so I washed the plastic bag out and kept it for the next fishing trip. Now, this is a banal story, of course, but, I don't know, 2 years ago, the whole place, the whole house would have been full of plastic bags, and now it's not. So that plastic bag actually became a valuable commodity for me, rather than being just something which we chuck away without thinking. Again, a simple decision. We're not going to have any more plastic bags. Well, nobody died. People lived actually as a result. So smoking and the plastic bag, I think, are very interesting examples of how quite simple decisions, which are probably democratically supported, but need to be taken in a slightly dictatorial way, make quite a big difference to our society. This is an extract from the Digest of UK Energy Statistics, known in shorthand as Dukes. And it says here, renewable share of generation reached a record 33% in 2018. Well, 15 years ago, that number was 2%. So I don't believe we as an industry have made enough of that extraordinary achievement. So we've gone from almost nothing to a third of our electricity being produced by renewables in 15 years. Now that shows how, if the engineers and business people, I suppose, are allowed to get stuck into something, we can produce a dramatic change really very, very fast. So the problems on the whole are not engineering, they are political, with engineering coming as a response to political demands. So how did that happen? Again, I think a very similar way. There was a directive, a EU directive. So there we are. Something good came out of the EU, I suppose. So what would we have done without the EU? And this, would we have signed up to it? I don't know. But the EU directive said that we had to have 20% of our energy, not our electricity, 20% of our energy by 2020, or else. And the else was a huge fine. Now this was a pan-European, well, all countries within the EU. And basically, we've simply responded to this diktat. So we were told, you better have this renewable energy, otherwise you will be punished with large fines. And lo and behold, what happens? We're probably not going to quite meet it, but we've gone from 0 to 33% of electricity, so that's quite different. And I'm afraid that's I'll be making that mistake repeatedly this evening, I suspect. But electricity and energy are far from the same thing, and so it's probably more like 30% probably more like 40% of electricity will be needed. So we were told to do it, and we did it, and it's been truly remarkable what has been achieved. And last week, the latest prices in the offshore wind market were announced, shown here, these last two here. So this is, you don't have to worry too much about all the units, but this is the price of energy from bidding into an auction, offshore wind projects bidding into an auction to be delivered. So in other words, projects to be commissioned on the x-axis. So these ones to be commissioned in 2024 to 2025. So the price has more than halved during that time, as a result mostly of multiple installations and getting better, practicing, also people getting confident, both financial people and technical people and political people. And to be fair to the politicians, despite initially quite a sharp rise of prices, they've stuck with the promotion of offshore wind through different colours of our different governments. Same time, that's the original price for Hinkley, but of course you may have seen again last week, almost on the same day as these prices were announced, Hinkley also looks like it's going to have a huge surge in costs. So I think this is a pretty remarkable story. It's a remarkable story in engineering terms because it's all about these huge rotating machines, which we'll talk about a bit later on this evening. And it's about a policy which is effective. So we have an EU policy saying you will do it. We have the execution of that policy with a particular form of incentive. In Britain, different countries had different incentives. Our incentive has worked to reduce those prices from about, actually it's about a factor of 3, about 150 down to about 50. So that's really a very interesting history of the last 15 years or so, from the beginning of offshore wind to now, where it's become a main supplier, one of the main suppliers of electricity for the UK. Now, it's interesting, the Queen is getting involved in lots of stuff now, and she may have been surprised to read this headline. So this was reporting the declining cost of offshore wind, but rather than sort of say, what a fantastic engineering achievement, it was Queen set for financial boost, because she owns the sea. You know? So I thought, well, okay, this is a strange spin, but at least it made the headlines. We have to think on a large scale. So we have had quite a few no-coal days now, and they're going to become more and more frequent. So coal is out of the picture pretty much now, certainly in the UK, less so in other European countries. So we have to think on a large scale. One of the thoughts was the local Swansea Bay Lagoon, so build a big wall and fills with water as the tide comes up, and the tide goes out, the water comes out through a turbine. But that's been cancelled. I suspect, actually, they made a mistake of doing it first in Swansea Bay. It is huge, but they should have had a bigger one, because a bigger one is quite a lot cheaper. Anyway, it's cancelled, and as a result, instead, we are getting Hinkley, roughly twice the price of offshore wind. Whereas we could have had more of offshore wind or some of these. And of course, PV is growing, although it is quite low density. Offshore wind is certainly pushing wave in the future very effectively. And wave and tidal are faltering right now, particularly wave, I think, is a bit questionable. But my firm conviction is we need all of these, and maybe we need nuclear too, but we need all. There isn't going to be one answer. There's going to be a whole panoply of answers, a whole spectrum of solutions, and we need to adopt them all and promote them all, because we are going to be very short of energy if we stop burning any fossil fuels. And we've shown with the development of the offshore wind over the last 15 years that it can be done. So what about the physical scale? What am I actually talking about? The physical scale, I think, is terribly difficult to really portray without physically visiting one of these installations. So you can talk, and I will talk, about a 171 meter diameter turbine. And you can think, wow. And you'd be right to think, wow. But until you actually see the damn thing, it's impossible to realize how loud that wow should be. So here, and I call these, normally we call them wind farms probably, but they aren't really wind farms, they're really power stations. So here is an American wind power station, looking very similar to a Chinese wind power station, but looking substantially different to a big European one. And, of course, the reason, apart from Spain and a bit of Scandinavia, there really isn't much room in the European Union. So that's why we've gone offshore. I mean, you'd be mad to go offshore, really, unless you had to, because doing things in the sea is a great deal more complicated, difficult, and expensive than it is to do things on land. So the lack of space is the main reason why we've gone offshore. But here's another. So this is a picture, and I hope this will work. This is a blade, an Enercon blade. There are 3 of these blades for each turbine being delivered to a Highland site. Is he speeded up by a factor of 3, I think, or so. So you can think, well, is this really a sensible thing to be doing? 3 of these for every windmill. But I think you've got the picture. So there are other reasons for going offshore. So in fact, I think another reason for going offshore is simply that there is an economy of scale as turbines get bigger, but they get to the size where you can't deliver them. So it isn't about fatigue, it isn't about loads, it isn't about vibrations that's limited the size of the turbines onshore. It's you can't get them under the railway bridge, or you can't get them, in this case, around the corner. So I said in the blurb about this talk that I'd also give a bit of history. And so I'm going to start really right at the beginning. So here's 1,000 years of innovation. From these Persian wind turbines on the left, which are still there, to the standard Dutch, Danish, German ones on the right. So we've been living with power from the wind for a millennium. And then we moved to 100 years of innovation, and rather unusually, I've chosen here some Soviet wind turbines, because normally, if you look at this in this sort of history, you'd start probably in the 40s or 50s in France or Britain or America. But I recently discovered this really rather interesting activity. So in the 1926, Chagi, which is it was the Soviet Center for Aerospace Research, still exists now, and started actually by Tchaikovsky, who, if you're an aerodynamicist, you will know very well. Some claim he invented lift. I think that can't be quite true, but he may be a bit lame. So in the 20s, Tchaikovsky and Chagi were developing wind turbines, and you can see actually quite complicated ones. And this one was actually built. So this is 100 kilowatts, 30 meter diameter. So they were actually leading the way then. Then we moved through the 70s, and you can see this is a different style to it. This is quite a famous wind turbine, quite rather nicely called Tvind, built by a Danish school in the 70s, and you can see the general demeanour of the people is quite clear, and that bus is I think a very, very iconic bus. So this was a 1 megawatt turbine built by this school in the 70s, and this was quite an important turbine, in fact, in cultural terms. This gives you an idea of the level of technology that we were using in the 80s, and I think there's a health and safety officer in here, but I'm pretty sure this is not something the University of Bristol would approve of. So we've moved from this in the 80s to this is an LM, a glass fibre blade test facility in the present day. So there was a lot of turbines, particularly in the late 80s, early 90s, which were driven, the market was driven by a tax credit in the States. So I thought I'd talk a little bit about different forms of motivation. So I've talked about the EU 2020 and how that happened. There was a huge amount of activity in the States. The States in this time was the main market, often supplied by European turbines. And this is a Micon turbine, and their slogan was powerful simplicity. And their turbine is Micon 108 on the left here. And were put out in huge numbers. And they were driven by a tax credit. So you got a tax credit if you build a wind farm. And the motivation had absolutely nothing to do with the environment. It was a very American approach. This was all driven by money. And sometimes these tax credit bills were mixed up with shopping centres or motorways or all sorts of other deals were being done. Nevertheless, whatever the motivation was, this produced a huge spike of activity in the market and then engendered a lot of manufacturers, small manufacturers, to get involved. In those days, I coined a phrase which was survival is success. So you weren't talking about optimizing things. You weren't talking about minimizing costs. You were just thinking, oh, will the bloody thing be up tomorrow morning? You know, that was the level of concern. So these turbines might have worked with, say, 60% availability, which meant they'd be available for 60% of the time, and other times they would be faulted. Now, in a commercial wind farm, you would be very disappointed or angry if that number wasn't 98.5%. So things have changed dramatically. I wanted just to throw in a few bits of technical engineering as well. And this is the same era. In those days, there were a lot of turbines which had their power controlled by stall. So on the right-hand side, and aerodynamicists will know this back to front, of course, but for those of you who aren't aerodynamicists, the wind comes past the blade, like the bottom picture here, under normal circumstances. As the wind gets higher, the blade stalls. And as the blade stalls, as the blade stalls, the lift drops off, and this means that the power dropped off. So there was a lovely natural way of limiting the power. You didn't have to move the blade, twist the blades like we do now, like a propeller. They just sat there, and then the blade stalled naturally, and it was simple. It wasn't as precise as it might be with a rotating blade, but it was simple. But then we got to a certain size, the LM19 blade, so that means a 38-meter diameter turbine, where the thing just fell apart in seconds. And you could have one turbine sitting right next to the other, exactly the same turbines in apparently exactly the same position. One would explode, not explode, it would vibrate to pieces, but in seconds, and the other would be completely benign and continue operation. So there's a bit of basic physics in here, which we really haven't got to grips with. And I think, well, probably the turbines now are far too big for this, but it seemed to me a shame that we had to stop at that size, simply because of the violence of this stall. So if we were a bit more sophisticated and we could do better aerofoil design or understand rotating stall a bit better, we might be able to do something quite different. So that was just a sidebar. And a similar sidebar is lightning. In the early days, lightning used to destroy loads of turbines. And you can see, here's a lightning storm in Italy, I think. And there was no damage. All the turbines were fine. So here's a bit of nature which we've cracked reasonably well, I think. So dealing with nature, earning your money with the elements is quite a challenge. So this sort of stuff, this sort of picture, and actually that one, teaches you to be pretty respectful of what nature or the elements throw at you. So that 100 years, starting with the Soviet turbines, really gets us to here, where we could call this a commodity turbine. So this is not an offshore turbine, this is a turbine onshore, but really has become something which you buy not exactly off the shelf, but you can order 10 or 100 or 6 of these turbines. So that progression is a very interesting progression to see. It has become a commodity. So now we're not worrying about whether it'll survive. We're not worrying really about efficiency anymore. We're worried about eating away at the cost of these turbines, just like you would with another mature technology. We have not yet got to the stage of the automotive industry, I think, and I look to that very much with dread in a way, but also with admiration. So I had quite a few children at one point, and we had a Renault Espace, and then the children all grew up, we kept the Renault Espace, and then eventually it all started falling apart at the same time. I mean, really amazingly. So the constant velocity joints, the gearbox, the back wheel bearings, within a month, I would say, they'd all bust. So you think, blimey. Well, of course, you think, blimey, this is rather annoying, I've got to pay for it, but you also think, this is really clever, because they've understood so well their product, how their product behaves, or they've done such careful calculations. I think it may be a bit of pragmatism as well. So you get the whole thing to fall together at the same time. And that is a sign of maturity. We aren't there yet with a wind turbine. If you buy a car, you might keep the car. The car might have a lifetime of, I don't know, 10, 15 years. It actually runs for about 9 months in total, its total lifetime. So if you add up the number of hours used, it's about 9 months is actually pretty heavy use of a car. So that car is running for 9 months and then it falls apart. Well, these things have a lifetime of, let's say, 25 years, of which they're running for 15 years. They're going around for 15 years. The car is going around for 9 months. This is going around for 15 years. If you take a helicopter, which is going around a lot faster, of course, but every few minutes it's on the ground being looked after by expensive mechanics. So this is quite a remarkable bit of machinery, just in terms of its survival with we hope, limited maintenance or very much controlled maintenance. So, one of the main innovations, I would say, from the beginning until where we are now, has been control. So it's computers, I guess, you like anything else. So I showed you the Micon 108, whose slogan was powerful simplicity. And powerful simplicity was a very good description, I think, of the technology. So the technology was essentially agricultural engineering and small boat building. So glass polyester and glass polyester blades and agricultural engineering from the mechanical bits. So it was pretty much like a tractor. And then the wretched computer came, like the rest of our lives, and so collective pitch started. So that means rather than these blades just sitting stationary and being untwisted and stalling to control power, we started to actively control these things, with both blades or all three blades doing the same thing. Then torque control came in, so that meant variable speed. You could control the torque of the thing. The speed would start to move up and down, so you could rotate at the optimum speed for the wind speed. And a new type of generator, the double-phase induction generator. I won't go into that now. Then the gearboxes were removed by direct drive generators. There's a whole new type of generator appeared, which was bigger, but actually more efficient, but it was a permanent magnet or could be other designs. So permanent magnet generators arrived. Then we started to plaster sensors all over the place, going back into the computer. Why not chuck in a laser? I mean, might as well. So this laser is looking forward to see what wind is going to come and hit the windmill. So getting ready to twitch the blades so that the loads are kept under control. So this is a bit like a fighter aeroplane, that part. Individual pitch. So now, instead of moving the blades together, essentially controlling power, the three blades have lives of their own. So the whole thing is twitching like a helicopter. So I think a way of characterizing the development of the technology from the early days, the powerful simplicity, to where we are now, is moving from quite a simple tractor to a pretty sophisticated helicopter, but a pretty sophisticated helicopter which does not have the benefit of being polished every time it lands every few minutes. This thing is usually in the sea now and left to get on with its own devices. Then finally, that's the turbine. Then we add a wind farm controller. So now the wind farm is also got that. So all the individual turbines are looking after themselves, but there's now a wind farm control which is telling some of the turbines what to do. And these wind turbines produce wakes. So behind the wind turbine there's some low moving air. So the wind farm controller, for example, might steer those wakes. So if one turbine is sitting behind another turbine, sitting in the wake, it can move, can twist the one in front so that the wake comes past the one behind. So, there's all sorts of games you can play. So it's terrifically exciting, and it's big data, which is good. It's very trendy to have big data. So we've got lots of big data. So 3 decades of development. I've added their personal development. So when I started, this is the first. This one on the left here is the so-called Storemaster turbine, which was 12 meters in diameter, 60 kilowatts. The first project we did in America back in the 80s. And I could carry that blade on my shoulder. So I could carry a windmill blade. Well, now, a big wind turbine blade, or big wind turbine, is 3.5 times the size of Wembley Stadium. So that's another way of looking at it. So we've gone from that to that. I've seen it happening. I regard myself as being incredibly lucky. And there's a few other people, I think, in this room who had the same experience. to being in the beginning of an industry which has been very successful commercially and technically, but also what an education. I mean, to have gone from that, we never dreamt when we were fiddling around with those Storemasters, what we might be fiddling around with later on in 2019. Well, here's a picture of, now actually this is an interesting picture because this was produced by the European Wind Energy Association in 2009, looking into the future. And actually, when our company started, when Garrad started back there, but this is not the future, this is now, and that wasn't supposed to happen until it looks like about 2030. So even in 2009, we were doing a terribly poor job of predicting the quite close future. So we already have 150-metre diameter turbines, which according to the EWA 10 years ago wasn't going to happen for another 10 years. So things are moving incredibly fast. And just a little personal note, actually Steve Jilks is sitting in the back there, this is really his slide rather than mine, but these are turbines which Garrad, led by Steve, designed in Bristol, including at one point the one at the bottom, the world's largest machine, which we designed for Samsung. So this was going on in Bristol, which is also quite a nice and exciting thing, I think. So turbines were growing in complexity as well as size. But then I wonder how that's going to go on. So, I don't know, probably some of you have been on a A380, I've been on one a couple of times, and it is an extraordinary thing, although it's quite small, actually, compared with a big wind turbine. That's not the point of this slide. I went to see Ian Gray, who was the boss of Innovate UK, but before that he was the chairman of Airbus UK in his office in Swindon. And outside his office, proudly, he had a model of the A380. So I was able to say, well, Ian, that's quite a nice little machine there, but you should have something, a proper big rotating machine as well. So the A380 is going out of production. And that's something I think to pause and reflect upon. So why has that happened? It's an extraordinary engineering achievement, that aircraft, but it hasn't met the requirements of the market, of the economics. So if we look back here, almost all the effort, engineering effort, has been put into making these turbines bigger and bigger and bigger. And with that has become cheaper and cheaper and cheaper electricity, up to a point onshore where, as I showed you, you can't deliver them anymore, so you stop. Offshore, who knows what will happen. But at some point, we may get to an A380 moment and have to think again. Why? Well, they aren't all the same, but I know if you have a quick look at them, they all look the same. They all look like that. So why do they look like that? And the reason is that they have to be onshore, they have to be good neighbours. So we used to work on two-bladed machines, and they were fine from an engineering point of view, but people did not want to live next to a two-bladed machine. It looked like it stops every time it goes past the tower. So it was a really upsetting thing to see. But from an engineering point of view, from a cost point of view, it was effective. You might want to have the turbine, the blades upwind of the tower, but if you do that, downwind of the tower. If you do that, you get a thump each time the blade goes past the back of the tower, because it goes through some dead air. You might want to run faster. I mean, to be more efficient aerodynamically, you would run faster, but then it's too noisy. So they all look like this because they have to live next to human beings. So they had to be good neighbours. They no longer have to be good neighbours. So offshore renewables, or maybe I should say offshore wind, are really an engineer's dream. We have to look after the sea life, particularly during construction. But otherwise, you can chuck away all the social limitations produced in the past by being a good neighbour to a human. So therefore, we can expect, and we should expect, that in the long term, the offshore turbines will not only be bigger, but will be different. Bill Gates, and since it's Bill Gates we have to take notice of, I suppose, he said we need an energy miracle when he was discussing the whole business of electricity generation. Well, I would say to Bill, well, actually, I think we've already got the miracle, The miracle is we can do all this stuff. And we just need to do more of the miracle. And so the miracle suggests some really deep thinking. And I think we've done the deep thinking, we just need to do the implementation. And that isn't just the turbines, it's everything. So the innovation will come in all those different bits. And onshore, the turbine is probably 75–80% of the cost. Offshore, it's less than half. So all these other things become very important. Here's a big blade. And again, if you see this big blade, you would be gobsmacked. And so it's the size of 9 double-decker buses, one blade. So seeing it here just simply does not do it justice. It's an awful American word. In the true sense of the word, it is awesome. Not the American sense, but the true sense. It is awesome. But it also gives us, I think, a problem. So we consider ourselves to be a clean, environmentally friendly industry. I mean, after all, that's the driving force behind it. But we don't really know what to do with these things at the end of their lives. So we're building these huge composite structures. But how do we get rid of them after they've been running for 25 years or so? And there's quite a lot of work going on in that now. Either just direct use of the material or avoiding this problem. Can we be more clever about the materials that we're using to develop these blades? A new problem that's emerged recently, offshore, not onshore so much, is leading edge rain erosion. And I think there's some work actually being done here in Bristol. So this has been a bit of a surprise. The turbines working offshore are working in a wetter environment with sea spray and rain and are damaging quite substantially some of the leading edges of the turbines. I've chucked in a couple of sort of eccentric ones here because I've now learned from experience that you should never dismiss an idea, however wacky it appears to be. And I must say, this one on the left, I felt very much inclined to dismiss, but actually in the Garrad Design lecture last year, I think, we had someone talking about kite systems, and I've seen some running. So here's a kite which gets way up into the higher wind speed air and drives some pulleys on the floor. And on the right-hand side is a floating vertical axis wind turbine. So maybe this sort of thing will appear. Here is a multi-rotor. So this sort of thing was envisaged back in the 60s and 70s, and then built in the 80s by a Dutch company called Lagerwey, and now more recently Vestas, which is probably one of the three main turbine manufacturers, has built this multi-rotor system. So this is the sort of thing that might appear offshore simply because you're relieved of the social constraints and you only have technical constraints. And here's a kite. To me, it doesn't look like a kite, but this is called a kite. It looks surprisingly like an aeroplane to me, but anyway, it's called a kite. The offshore activity is mostly so-called shallow water, less than 50 meters depth. And you can see from this graph here that we are very well endowed with such water around Northern Europe, particularly between Denmark and Britain. So that's where most of the activity is. But elsewhere, there isn't so much. So floating wind turbines are now starting to emerge. And the first floating wind farm actually was in Scotland, but there's activity around the world. And one of the very first ones was built in Fukushima. And here you can see the floating wind turbine in the front and the burnt out power station in the back. So this is rather an iconic photograph. In Japan, there's not much room on land, and what room there is very, very complicated terrain. If you go offshore, when you're a few meters offshore, you plunge a few hundred or even 1,000 meters very quickly. So the offshore waters around Japan are terribly deep. So you couldn't use a conventional offshore wind turbine solution in Japan. You have to go for something like this. So this has produced a whole new type of activity, I think, another bifurcation of innovation. And this was a gesture towards solar. this is a Chinese floating solar power station, which I really like. And this is a typical Chinese approach to things, isn't it? You just do it. Do it, so much of it. If it all goes wrong, just do it again. So we've done a lot of work in China, and in Britain there's a stigma. If you're a Western engineer, there's a stigma attached to failure. So we do prototype testing or design, prototype testing, fiddling around, zero series testing, and then eventually we produce a commercial turbine or whatever product is. In China, the stigma is attached to inactivity. And it doesn't matter what you do, as long as you do a lot of it really fast. Which when you start in that market is really frightening, and when you get used to it, it's really exciting. But it is just a completely different approach. So it's no surprise to me that this is a Chinese project rather than a European project. But it's lateral thinking, isn't it? Maybe they haven't got much space, so do this. What about the fuel? So it started with the oil. The first pictures was of the oil. Well, the fuel, of course, for wind is the wind. The glamorous bits of all the development are basically the size of the turbines. But there's been a huge amount of activity in defining better and better what the resource, what the fuel is like. So when I started, there were two ways of measuring the wind. On the left-hand side here is what's called a Thaler kite, and you can probably see there are red streamers and the kite at the top. And by looking at the tension on the string and the inclination of the kite, you made an estimate of what the wind speed was like. And on the right-hand side is a ubiquitous anemometer, cup anemometer, which I'm sure you've all seen. So basically, we were making spot measurements with an anemometer and the occasional measurement with a kite. And then late last year, this Aeolus satellite was launched, and its sole purpose in going into space is to measure the wind around the globe. So to be used specifically for resource measurements for wind. So there it is, looking down at us, and well, God on the left-hand side is helping, and I got into trouble quite well in the States, particularly for this rather sort of offhand remark. But I used to say we did a lot of project finance for big projects. Basically, you can fix anything. If the gearbox fails, the blade falls off, if the tower vibrates, there's an engineering solution to it. So you have to spend the money. You don't want to spend the money, but you can do it. If you've got the wind resource wrong, there's nothing you can do about it, unless you have very good connections with this guy here. So there are quite different types of problems. So understanding the resource, understanding the wind, and getting a really good quantification of the wind with all sorts of computational fluid dynamics and so on as well. It's been a huge revolution. So we used to have very sparse data. Now we actually have quite a lot of data. And then local measurements here as an example, this yellow thing in the front is a floating LiDAR, so it's offshore. Actually in the back you can see there's a conventional mast which has got anemometers all the way up it, and this is the modern equivalent. So this is a laser pointing up from the sea and measuring the same thing as the mast. I'm almost there. So I've talked about the machines. I've talked a bit about the resource and the wind farms themselves. What about the electricity? So if these little green squares were wind farms, it's 800 by 100 kilometre wind farms, that would supply the whole of the EU's electricity demand. Of course, next month we can have less. So that would be amazing. So last year we only had to, now we only have to have 6. Let's hope we still need all 8. But anyway, so basically resource isn't the problem. And it's true also with waves, it's true with tidal, it's true with sun. There's loads of the stuff. There's loads of wind, there's loads of waves, loads of tides and loads of sun. The resource is never the problem. The integration is the problem. So we have a grid system which is set up to have central generation The Dutch word for power station is centraal. You have central generation and radial distribution or transmission. Well, now we have these power stations all over the place. Probably, most likely, the windiest places are the remotest places in many countries. So this is, I think, an area of real serious activity now. And it isn't just technical, it's also cultural. So this is quite a nice quote from the boss of the National Grid. And he said, 2015 was last year where we'd be running the grid like we always have done. So the arrival of renewables, but probably particularly wind, is creating new thoughts of how to control the grid and how to do it properly. Now, I've seen a very interesting transition. In general terms, you call these the TSOs, transmission system operators around the world. The initial reaction of TSOs everywhere was to be patronized and say, well, okay, we'll connect these wretched things if you want to, because they're not going to last long, it isn't a serious thing for the future. Then the windmills didn't go away. So then there was very, very aggressive, techno-aggressive behavior by the TSOs trying to prevent sensible connection of renewables to almost every grid. And now we've moved into this sort of regime where it's been recognized that there's a political reality that renewables is going to be part of the energy mix. And so their job as TSOs is to integrate those sources of energy onto their grid, onto our grid. So it's been very interesting to see that transition, that change in culture. So it's also about culture and people. Now here is a disgraceful picture of a European Wind Energy Association conference a few years ago. And you can see diversity or inclusion is not our strong point. And we do look extraordinarily similar now, but I want to point out one thing, which is my shoes are brown. There are, in the last EWEA conference, there were 30% of every panel, I think at least, was female. But there's a woman here thinking, oh, bloody hell. So there's a lot of room for change here. So I'm afraid this is a disgraceful photo, and it is real, although I think it is changing. Short-term forecasting, so I've talked about the grid, I've talked about the machines, I've talked about the resource. But we can't expect now this energy just to be accepted into the grid. It has to behave as much as possible like conventional plant. So this is a graph of short-term forecasting. The red is the actual power, so it shows the actual power produced by a certain wind farm. And the blue is the prediction, hour by hour, I think half hour by half hour, a day ahead. So what will the turbines be producing at 7 o'clock tomorrow? And you can see, depending on your point of view, you can see, if you're a scientist and you look at this, you say, well, that looks pretty good. We've got all those patterns right and similar shapes. If you're an energy trader, you might say, well, bloody hell, you're in the May the 14th in the afternoon, you're 100% wrong. so it is very interesting, and that sort of the small scale accuracy is being worked on continuously and is improving. So we're bidding regularly into energy markets. I wanted just to mention energy storage, because I think I say here, energy, what is it? Well, it can be a battery, it can be pumping water up a hill, it can be dropping a weight down a mine, it can be a rotating wheel, it can be anything. And of course there's a huge amount of activity now and endeavour generally going on to energy storage. So is it just the Holy Grail or not? I think there is now a lot of progress being made in this field, which does mean things will change, and it is necessary. But it's a question, you can say, what do we mean by storage? Do we mean a gigawatt for a microsecond, or do we mean a kilowatt for a year? So there's all sorts of energy storage, heating up rocks, compressing air, everything. So this is a whole new area, and I think someone asked me the other day, we said, a similar sort of audience, I suppose, say, well, you've been very lucky, you've got into the very beginning of this wind energy business. What would you think, what's going to be the equivalent for us? And I suspect that this may be it. Energy storage could be, in 5-10 years' time, could be anything. Right, think, I'm not going to go through this in detail, but this is my attempt, without any units or scales or even an axis, to decide what's happening. We've come from our onshore turbines, they're now a commodity. They're amazing machines, but they are a commodity. It's a bit like a car or a lorry or some other thing. The aerospace and big funding capital funding of projects started us going there, and they joined in there. The fixed offshore, so the conventional offshore, I think has broken away from the commodity onshore turbines, and they will have a life of their own for the reasons I mentioned, because there is no limitation by being a good neighbour, there's no limitation on size, there's only the driving force is how cheap can we make electricity. And then I think offshore floating is going to be completely different again. So it'll start looking like an onshore turbine or an offshore turbine sitting on a float, but it'll become something else. It will develop a life of its own, and the solutions which you may see may be quite different. From that, there may be completely different things. I showed you the vertical axis wind turbine, I showed you a kite, but it might also be multi-rotary, and it might be something we haven't even thought of yet. So I think we're just beginning. With the floating offshore, we're absolutely just beginning. The fixed offshore, it's only about 10 years old, so compared with conventional technology, power generation, etc., it's still very young. And it might be something else. So that's a very useful statement. So I think it's a mistake to think they may all start in the same place, but I think they will progress to quite different positions. Just finishing off then with a little bit of scale. So there is a Mitsubishi Vestas 164 metres, 164 metres in diameter. One turn of that turbine, about the same size as the Gherkin, will send a BMW i3 40 miles. So that's another way of just trying to get to grips with the scale of what we're dealing with. And here is my car, not in my house. And I think I've now got the second one of these. I bought the first one of these in 2015. And I told you about our Renault Espace that fell apart. So we had to buy a new car. So I thought, well, we should look at this electric car. And I said to my wife, I think we shouldn't buy this electric car because in a couple of years it'll go twice as far as it does now. And at the time, I was the chairman of the European Green Capital in Bristol. And she said, well, look, you're the chairman of the European Green Capital. If you don't buy this bloody car, who's going to buy it? So I said, okay. So I bought it. And then, lo and behold, 2 years later, the same car goes twice as far. So I'm just going to end then with Victor Hugo. Nothing can stop an idea whose time has come. And I think it's very much the case of renewables, but wind in particular. Thank you.
Thanks, Andrew, for a really inspiring talk. We have got time for some questions, so would anyone like to start with a question?
Yeah. I wonder if you care to predict the cost curve out to 2030 or 2040, something like that. I'm just wondering how much more years of this amazing cost reduction can continue, and do these things need to keep getting doubling in size, or is there reasons for it to cost?
Well, I think there are these learning curves, I think, which you probably have heard of. So the reduction in cost with a doubling in volume. And I think we are, with onshore wind and with offshore wind, we are ahead of what will be a conventional mechanical engineering curve. My guess is that offshore, perhaps I can go back to that. Me or find that graph at the very beginning. That it's starting to flatten out. Sorry, onshore it's starting to flatten out. And I've repeatedly referred to it as a commodity. And I think when it becomes a commodity, things will go on getting cheaper, but we won't be measuring that in 5, 10, 15%. We'll be measuring it in 1 or half, or point, like in the gas turbine now. I mean, if you can squeeze 0.3% energy out of a gas turbine, it's amazing. And we've been measuring our progress in big chunks. So I think onshore we've got to that point already. Offshore, I think we haven't. And what we've seen here is partly engineering, but it's also a big chunk of it is business confidence. People prepared to it. So initially, you think these things won't work. They'll fall apart. Actually, some of them did fall apart within a few months. So we cannot afford to invest in these billions of dollars in something that we can't be sure about. Now that's pretty much gone, and I think we've also learned other lessons. So we are getting better at building what we've got. Confidence is building, political confidence is building, and cost is reducing. But I think this is only a few years old. So I only expect the costs to go down. I think you probably didn't realise I'm bullshitting, so I'm not going to give you a number. But I'm expecting the cost to go down quite substantially with offshore wind, mainly because of volume, actually, rather than because of technology. Volume, confidence, and just practice. And very interesting things like when we first started, there weren't any vessels that could manage these things. So what do? You've got this huge bit of kit to put up 150 metres in the air, in the middle of the sea. Well, now they exist. And I think it amazes me how aggressive and confident people are in building new kit to support it. So in order to do that, you have to be confident in the market, you have to be confident in the politics. So I think we're now in a sort of virtuous circle. So we won't see factors of 3 in 10 years ever again, but we will see a continuous downward trend, I'm sure. So that's a non-answer, but it's a...
You built an incredibly successful technology business to do with wind and Garrad and sand, and obviously the technology has moved on, times have moved on now, and I wonder if you were kind of back at the beginning again, or if you were advising undergraduates here in this room, kind of where the opportunities might be, what you would go for. You obviously had tremendous insight when you got involved in wind and Garrad and sand, and that paid dividends. What you might advise people, and I'm kind of thinking, things have moved on. You talked about engineers can do anything, they just need the political motivation, but there are obviously some technical challenges to kind of continue to increase the impact of wind. Maybe they're to do with energy storage, maybe they're behavioural. I just wonder, what would you focus on?
Yes, right.
You doing it all together?
I think you're quite right. I mean, I would throw it, you've been very kind of what you said about me, but I would also throw in a good chunk of luck. I mean, being in the right place at the right time is very helpful. And this could be the right time too, because I think I do sense a sort of mood change in Western society at least. And so I think probably most jobs now, well, in the next, say, decade or so, are going to be, sustainability will be part of them. It doesn't matter what it is. In a rather banal way, and the reason I started with that plastic bag, I think the changing people's, the changing culture, changing people's attitude is probably the most powerful thing. So that there will be, probably in the next few years even, there will be flight shame. So people won't fly so much, and people will think very much about flying, and people will think, where is our energy coming from? They will think where is our food coming from? On a more, on a more prosaic technical front, I think storage is where I see the biggest, potentially the biggest and the most exciting technical changes to be made. And with that, I would chuck in grid management. I mean, that's perhaps not as glamorous, but hugely important.
Can you be more specific in storage?
No, I can't. Because we had a board meeting, when I was still running the company, we had a board meeting where we decided to get into storage. And so I asked one of the board members to come back to the next board meeting and tell us, what he thought we should be doing. And he, actually, perhaps what I said in that slide there came from it, which was, what is it? Is it pumping water up a hill? Is it heating air? Is it squashing air or heating concrete? Is it spinning wheels? Is it chemicals? I don't think we know yet. Is it hydrogen? I mean, I hadn't even mentioned hydrogen. So I'm certainly not competent to answer that question, but I do think it's a huge open question. And to make the transformation of society that we need, I mean, everything becoming electrical, storage has got to be a key thing. So I would say to someone who was wondering a technical person wondering what sort of direction you're going, storage would be the top of my list. But I do also think that what we've done here is still, I mean, we think it's gone a long way, but probably we've only just started, really. And I think applying lessons from other industries is very interesting too. So it's taken a surprisingly long time, in my mind, for aerospace, or for us to talk properly to aerospace, for us to talk properly to automotive, for us to talk properly to defence controllers. And there's a lot of maybe less glamorous but pretty interesting stuff which could be borrowing heavily from much more mature industries. Then there's wave and tidal, which I haven't talked about at all. And I think the tidal is an order of magnitude less than wave, or maybe several orders of magnitude less than wave in terms of its basic resource. I see it wave, I see very much like fusion. The goal, the prize is huge. And so we should keep going, even though we don't appear to be making much progress. It's the same thing with waves. The prize is just huge, but we seem to be struggling to make any real progress on it. So those two would also be interesting, if you were particularly mechanically inclined. But no, storage. The answer is storage. Yes. Well, if you buy a BMW i3, they will tell you that it's been built with wind power. I don't know if it's really true, but that's what they say. I can't answer that question directly, but I can tell you that if you put a windmill on, let's say, a reasonable site, so that means, say, northern Germany rather than southern Germany, or the Midlands rather than Scotland, the energy payback is about 6 months. So if you look at the amount of energy that was taken to build the windmill, it will have generated that amount of electricity in about 6 months. I can't tell you how that works out with fossils, but that's a sort of guiding principle. Well, I mean, it uses steel. There's a lot of steel in there, so we can't get away from that. It uses glass polyester, so yeah, it isn't carbon-free by any means. But if we got to the position where we could be making the polyester with the wind power, as BMW says they are with my car, and the same thing with steel is maybe more difficult, that may happen. We will be progressing that way. And if you think of a large chunk of industry is powered by electricity, and renewables produce a third of our electricity, then I suppose you can say a third of it is being done by renewables. So I can't give you the carbon numbers, but I think the 6 month number often surprises people. People often think that's going to be years and years and years, but it's actually quite short. And of course, you go to Scotland, it's a month or so, and if you go to Bavaria, you probably shouldn't put the turbine there in the first place, because
fundamentally change the grid system. So I was just thinking, so when you're changing such a large piece of infrastructure, surely that would take a long time, and I was just wondering if you thought that perhaps this would be something that might limit new technology in the future if the grid system can't incorporate.
Actually, I didn't quite say that. What I said was that the culture of the system operators needs to change. So I think there's a lot that can be done with our existing grid system just by thinking about it differently. And if you, I don't know if there's any old CGB people here, maybe not anymore, but in the old days of national utilities, everything was redundant. So if you needed one transformer, you had two. And that was just the way it was. And because, well, that was the culture. And the culture was to generate with huge central generators, like Sizewell B, for example. And if you've grown up doing that, and if you've been educated to that all your life, it's a hell of a job to suddenly change thinking, right, no, we're not going to do that, we're going to have all these funny bits and pieces all over the place generating. So I think the first step is just using the existing system in a different way. Second step is a lot of renewables. I haven't talked really about this, but I've only talked about the big stuff, but there's a lot of small stuff too. So even though a couple of solar panels on your house isn't much, if you add it up over the country, it's quite big. So suddenly the distribution grid, so the transmission grid is the national grid, which is the high voltage grid, and then the distribution grid is what's connected to all of your houses, which is run here by Wales and Western Power. So they're dealing with the low voltage grid. Now, they have almost no knowledge of how their grid works or how, no, that's unfair. They have almost no measurements on how their grid works because they haven't needed to. It's really not been necessary. So there's a big lot of activity now in instrumenting the low voltage grid or the medium voltage grid so they can do a better job with what they've got. Now, of course, there will be changes, and there are international high voltage links being built all the time, and will have, that's been going on for a long time. So I think there's a cultural shift, which is first, distribution system, knowledge, second, in the background, these big jobs going on. And then there is of course, quite a lot of geographical aggregation, which is very powerful. So if it's not windy here, maybe it's windy in Ireland. So if you are interconnected, that makes a big difference. But the other end of that is doing more and more locally. So communities, universities, individuals, that doesn't need new big stuff. It may need just doing differently locally. So yes, there will be some substantial investment, but I don't see that as a big obstacle for a bit. I think if we get, say, above 50%, then very likely we will have to do things. But what I'm encouraged by now is that the TSOs are thinking how to do it, what they need to do, rather than how to stop it. And I think that's a very, very positive thing. So yes, eventually, if we get to 100%, it'll certainly look a bit different. But there's quite a long way we can go with what we've already got. But the culture has to change.
You were talking about culture change. How do you think policies implemented by the government, like a carbon tax, would encourage that change? Because obviously when you hit something you want, they change.
Yes. Yes. Well, I mean, I think academically, a carbon tax is a great solution. I mean, it should work. I mean, it's a classical economic solution. The fact is that it hasn't worked, and maybe it hasn't been introduced or policed aggressively enough. So I think there is the big cultural question is how do you get people to shift? Now, one of the things that I've spent quite a lot of time on is well, I think you could say I've sort of lived on a cusp. If I'm in a Friends of the Earth or Greenpeace meeting, people see me as supping with the devil because I'm talking to E.ON and SSE and Goldman Sachs. And if I'm at Goldman Sachs, people see me as a rabid green warrior. And I think that is a bit the point of your question. So I've tried to say for some time that I think if we're going to make rapid progress, and we have to make rapid progress, there's no other solution, then people have to be able to make money out of it. Now, you may disapprove of that, you may not want that to be the mechanism, but right now it is the mechanism we've got. So you can, on the one hand, you can tax people, and on the other hand, you can incentivize people. And if you look at, going back to the very beginning of my talk with the 2020, each country was left with its own, will think of its own incentive device, how to achieve this goal. And people did different things in different ways. And basically, our mechanism was to allow big companies to make money out of renewables. That's a pretty uncharitable way of putting it. And it's worked. I think the fact is that right now, we really don't pay enough for our energy. I mean, the real cost of our energy are much, much higher. That brings you into a whole different question of fuel poverty or poverty in general. You know, is this just a dilettante, middle-class, rich person's business, or is it something which society needs? And I think that brings you into a much bigger question, which I think it's something that society needs, and maybe society needs to look pretty carefully at how it's organised itself. So my view is we can't afford not to do it. So we need to find a mechanism, and it might be taxation, it might be incentivisation, it might just be regulation. But what I'm very impressed with is if you have decided that's your goal, there is almost always a way of getting there, which may not be a way that people approve of, all people approve of. The problem we face now, particularly in Britain, I think, is we don't have a government, and the people drifting through the position of Prime Minister seem to be quite happy to say, yes, we should get greener. And this is a very good thing, saying, oh yes, well, we can do it by 2030, not 2050. Yes, fine. Well, actually, that's not good enough. Those big statements need to be backed up by detailed statements. And actually, going from 2050 to 2030, I'm really not interested in that at all. What I'm interested in is what we do now. Because it's a very comfortable thing to say, yes, we can bring in this stuff. But actually, if you're going to do it by 2050, never mind 2030, you've got to do a lot tomorrow. So I'm afraid that money, I think, is the key, which is not necessarily desirable from all sorts of other ways, but it is a proven way of making things happening, and we, unfortunately, right now live in a highly capitalist society, so that is the only way to make things happen. And regulation. So, a bit of dictatorial capitalism and regulation. It's a good university sort of approach to life.
How did you navigate running your business in an emerging market, being right at that sort of leading edge, cutting edge of technology?
My partner, a chap called Ansel Hassan, was a very good foil for me. So he didn't, as you probably already gathered, I quite like the limelight and the bullshit and all that stuff. And he didn't at all. So he kept the show on the road in the back room with a lot of discipline. And we also had complementary skills, so he was very good at measuring things and I was quite good at the mathematical side of things. We recognised, well, first of all, I think when we started, we had no work. So I mean, looking back on it, people think we must have had a strategy. Actually, we didn't have any strategy at all, which is bizarre, really. But we had a sort of youthful arrogance, I think, that we're quite clever and everybody will come and want us to do stuff. And remarkably, they did. And that was lucky, because at that point, there was lots of, in those days we used to have a Department of Energy, and we did a lot of work for the European Union, so there was quite a lot of useful money for us to keep going. But we had to make the market, so I've spent quite a lot of time with politicians in foreign countries, helping them to create a market, which we then help them to fulfill. So the reason why I felt it was okay to have this thing called, I think, technology and politics is, particularly latterly, I have spent a lot of time on politics, not party politics, but on energy politics. So we recognised we had to, right from the beginning, we recognised we had to convince people that they should do this stuff and that we could help them do it. And it was luck that the time was right. So lots of countries all over the place were looking at doing it. But I used to have arguments with Ansel, the guy with the purse strings, to convince him that I should go and spend 2 weeks in Morocco or somewhere trying to drum up business. And he said, well, no, you should bloody well come back here and go to Cardiff,
More question?
In the developing world, I wondered if you could share any observations about inroads that wind energy may or may not have made.
Yeah.
Any particular characteristics there, which are pertinent to the developing world, and maybe there'll be a bifurcation in technology, or maybe
Yeah, I haven't really said anything about that at all. That's quite a big omission. I used to think that there were two types of market. One, which I called the conscience market, and the other was the necessity market. So the conscious market is us. We've actually got lots of electricity. We've got more electricity than we know what to do with, but we think we should generate it in a cleaner fashion. And then there's a whole huge chunk of the world which has no electricity. And so the sort of solution that's needed for somewhere with no electricity is quite different to what we want here. And then there are a couple of approaches there. So I have done a little bit, not very much, a little bit of real rural electrical supply with small turbines. And I can't remember that. Do you remember the name of the huge Scottish chap with red hair and a kilt, whose turbines felt that the shaft broke? No, anyway, I went to the Philippines with this guy on a UK trade mission, and I talked about this. At the time we were developing a 40 megawatt wind farm in northern Luzon in the Philippines, and he was producing a windmill this big. And he was very tall. He was 6'7", and he had bright red hair and a huge kilt. And at the end of my talk, they said, "Okay, but please, come and talk to the presenters." And one person came to see me, and I don't know, 100 people went to see him and thought, "Well, actually, this is pretty interesting." So what he was doing, they actually needed and could use immediately. So that's real isolation. Probably that would now be replaced by PV, I think, rather than so small PV is much easier to deal with. Small wind turbines are notoriously unreliable and difficult, so that was long before there was commercial PV. The next stage, though, is in India. We've done a huge amount of work in India, where there was initially we were guilty of this. A very patronising sort of view. Oh well, in India they won't be able to deal with these huge turbines, and maybe the huge ones they could. We'll need to keep these ones smaller and come up. Well, we did come up with ways of erecting them without cranes, with A-frames and people putting on ropes and things, which work. But actually, what you found was, once it started, a local industry would develop which could support all the things, maybe in rather a more innovative way than we would at home, but could easily deal with medium-sized turbines. The issues so on the small, real rural stuff, you do need self-sufficient stuff, and I think that's a real problem because it's complicated, and you end up with computers with people who don't have the means to repair them, so you need something simple. So PV maybe is the right thing. Then you get into grids, so small grids, dealing with small grids. If you put in a half a megawatt of wind turbine into a small grid, and it's a very weak grid stability and controlling the grid becomes very big. Now, there are plenty of Indian manufacturers, there are Pakistani manufacturers, there are loads and loads of Chinese manufacturers, there are Filipino manufacturers who have got either got turbines under license, designed under license, or have bought a deal from a manufacturer. So we are seeing it happening all over the place, but I think it is much more difficult to introduce renewables, or no, more difficult to introduce wind into small communities, rural places, without grids. It's the grid bit that's the problem. So there was a lot of work done on wind diesel at one point. So you have a diesel generator, which you use when there isn't any wind, but then you end up with a diesel generator and a windmill, so two bits of complicated machine, and some damn computer trying to link it all together. And so it works when the World Bank specialist is there, and then as soon as they've gone, it's no good. So making things simple enough to be maintained, not to be understood, but to be maintained is very important. We did some work on St. Helena, which is extremely isolated, and I was fascinated to see how innovative people were when all they had was their toolkit and a bit of welding kit. They just did it. So they would maintain the thing in an outlandish way, but it worked. The clamour has all been on the big end, all the stuff I've been talking about. We haven't, I think, really used all the technology developments that we've created and reapplied them. If we go back to the 1980s when we had 60 kilowatt turbines, what would a 60 kilowatt turbine look like now if it was designed with all the stuff we now know? And nobody who was building those 60 kilowatt turbines, most of them, many of them have gone bust, but the ones at the left, the top end, are no longer building 60 kilowatt turbines. So it's a completely different lot of people. So I think there's often, people like to often talk about a battle between PV and wind. I think PV will win the battle. I don't see it as a battle, I see we both have to do it. I think PV is better suited to small isolated places than small wind, really.
That's a good note to end on. So thanks everyone for coming tonight. Hopefully there'll be more opportunities like these for you to come and see Andrew over the next 3 years during his time with us. But if you can just join me again, thank you, Andrew, for a fantastic talk.